let's try and graph the line x is equal to 3. And let's do it with an xy chart. Well, since our since our line says that x is equal to 3, then it really doesn't matter what value we put for y. X is always going to be 3. So we'll go to 3 and to -1. We'll put a point there when y is 0 and when y is 1. In all of those instances, x is equal to 3. So what we essentially have is a vertical line. So let's talk about the slope of this line. What does the slope equal? Well, remember that the slope is the difference of y over the difference of x. Now, going from the point, say, here, 3, 3, to another point here, say 3, 4, I've got 4 minus 3 over 3 minus 3, and that's supposed to be my m. But what ends up happening is I've got 4 minus 3 is 1 over 3 minus 3 is 0, and what happens when we divide by 0? This is absolutely verboten. We are not supposed to do that. So what happens is that our slope here, whenever we have a vertical line, our slope is undefined. Let's see what happens when we do something like y is equal to, and we'll go ahead and say 3 again. When x is equal to 3, it was a vertical line, so you guessed it, if y is equal to 3, then what we've got is a horizontal line. Horizontal line passing through that point right there. That all-important point is our y-intercept, and here we have a horizontal line passing through y is equal to 3. And so if this point here is 0, 3, and some point out here is 1, 2, 3, 4, 5, 3, then what is our slope here? Our slope is the change of y, remember the change of y over the change of x. That's our slope. And our slope in this case is 3 minus 3 over, say, 0 minus 5. Now, 3 minus 3 is 0. And 0 minus 5 is -5, but any number divided by 0 is 0. So whenever we have y is equal to a number, whenever we have our horizontal line, then our slope is 0. Let's take a look at a situation where we have two lines on a plane, and notice here that we have this green line. Let's see, it's got its y-intercept is at 0, 1, 2, 3, 4. The y-intercept is at 0, 4, and the slope seems to be, let's see, 1, 2, 3 over 1, 2, 3, 3 over 3. So our m is equal to 1 here. This line will be y is equal to basically x plus 4. And let's take a look at our red line. So our red line has a y-intercept at 1, 2, 3, 4, -5. So this is 0, -5. And it's got a slope of, let's go from this point to that point, 1, 2, 3 again. And oh, look at that, 1, 2, 3. So our m here is also equal to 1. So for our red guy, y is equal to x minus 5. And that's a very interesting situation. What we've got is two lines with the same slope. In this case, we have a slope of 1 and 1. So whenever we have the same slope, but different y-intercepts, we've got parallel lines. Same slope, but different y-intercepts. Now let's contrast that with a situation where we have very different slopes. But if you notice, this angle here, it's kind of hard to see, maybe my drawing isn't all that great, but that angle is a 90-degree angle. And our slopes, well, let's see if we can't write the equations for this line. This one has a y-intercept of 0, 1, and this one goes up 1, 2, See, 1, 2, 3, 4. It goes up 4 before it runs over 1, 2, 3, 4, 5. So the slope is 4/5 with a y-intercept of 1. So the blue line is y is equal to 4/5. 4 over 5 of x plus 1. Well, that's pretty cool. Let's do the red one now. The red one says it's got a y-intercept of 1, 2, 3. That's 0, -3. So this one, or if you want to look at it this way, it goes down 5 before going over 4. That's a better way to do it. It goes -5 before it goes over 4. Either way, it's the same horse. Its y is equal to -5/4. It's -5 over 4x minus 3. Now, as we already said, their intersection creates a 90-degree angle, and typically we'll call that perpendicular. And yeah, that is, but let's take a look at what it does, what perpendicular lines do with the slope. If I take the slope of the blue line, which was 4 over 5, and I multiply it with the slope of the red line, which was a -5 over 4, then I get a negative 20 over 20, or a -1. So you can always tell that lines are perpendicular when the product of their slopes is -1.